we're told that the probability of rain tomorrow, if it rains today, so if it rains today, the probability that it's going to rain tomorrow is 0.4. Which means if it rains today, then the probability of it not raining tomorrow, which I might call being fine, is 0.6. Make sense? Now, if it doesn't rain today, so if it's fine today, then the probability of it raining tomorrow is 0.25, which means that the probability of it being fine tomorrow is 0.75. So far, so good. Okay. We could draw a transition diagram to represent that, because basically we've got two states. We've got rain and we've got being fine. If it rains today, the chance of it raining tomorrow is 0.4. The chance of it being fine tomorrow is 0.6. If it's fine today, the chance of it being fine tomorrow is 0.75. If it's fine today, the chance of it raining tomorrow is 0.25. So there's our transition diagram. Is everyone happy with that? Okay. We're asked to find the transition matrix. So our transition matrix, because we've got rain and being fine, and rain tomorrow and being fine tomorrow, so it's going to be a 2 by 2 matrix again. So we've got rain and being fine as our initial state, and it's changing to rain and being fine the next day. So if it rains today, the chance of it raining tomorrow is 0.4, the chance of it being fine tomorrow is 0.6. Notice that our column again adds up to 1. If it's fine today, the chance of it raining tomorrow is 0.25, and the chance of it being fine is 0.75. So again, these add up to 1, these add up to 1. So this is like our little check. This is our thinking box, if you like. You don't put that in. It's our, like I said, a thinking box. Okay? So that's our initial state. Okay? Now, if we want to find out so if it's not raining today, and we want to find out what's the chance of it raining or not raining tomorrow, okay, then what we're talking about, so if we're talking about what do I call this? Oh, an initial state matrix. Oh, that's not actually an initial state matrix. That's a transition matrix. I knew I was going to make a mistake. An initial state matrix is just a column matrix. And the initial state matrix in this case is based on the information that you're given. If it's not raining today, if it doesn't rain today, then we're interested, remember we're talking about raining and not raining? So if it's not raining today, then the probability of it raining today is 0. The probability of it not raining today is 1. This is our so the initial state is what's happening right now today. So if and the initial state is always in the same order as what we put into our transition matrix. So the order of the transition matrix is raining on top, not raining on the bottom. So if it's not raining today, that means that it's not raining, it's 0. The raining effect, the raining impact at the moment is 0. There is no rain. Okay? The fine impact today is 1. Yep, it's not raining, it's fine. 100%, I'm pretty 100% sure that it's not raining and therefore it is fine. Okay? So, no rain means it must be fine. There's only 2 states that we can possibly have. Raining or not raining. So 0 and 1. So this is our initial state. If I'm interested in finding out if it doesn't rain today, what's the chance of it not raining on Sunday? Well, if today is Wednesday, and I want to find out what's happening on Sunday, I need to think about what's happening on Thursday, I need to think about what's happening on Friday, and I need to think about what's happening on Saturday in order to find out what's going to happen on Sunday.
Check the Bureau of Meteorology.
So apart from checking the Bureau of Meteorology, which is never right, because it said it was going to rain, it's often all weekend and it didn't. What we're doing is we're actually calculating onwards from today, which is Wednesday, and then we're working out what's going to happen on Thursday, Friday, Saturday and Sunday based on what's happening today. So, this is our transition matrix. Everyone's happy with the transition matrix? Okay. And this is our initial state matrix, which is based on the fact that no rain Wednesday means it's got to be fine on Wednesday. And so what we're going to do is we're going to multiply, because we're interested in what's happening Thursday, Friday, Saturday and Sunday, then we are going to be looking at this transition matrix for the 4 days, Thursday, Friday, Saturday and Sunday, and we're then going to multiply by our initial matrix. So we're going to take this transition matrix, let's call it T, because we're so full of wonderful ideas of things to call things. So when it's a transition matrix, hey, let's call it T. We're going to raise T to the power of 4, because there's 4 days that we're interested in, or 4 days that we have to work through to get to Sunday, and we're going to multiply by our initial state matrix, which, I know, let's call it I. And that is going to tell us the probability of it raining on on Sunday. So when we do that, again using our fantastic technology, what we get is something like 0.2931, right, which is the chance of it raining on Sunday, and 0.706033125, which is the chance of it being fine on Sunday. What do you notice that those two decimals add up to?
What?
What a surprise. We would be surprised if they didn't add up to 1. Okay, so this is the chance that it's raining on Sunday. This is the probability that it's not raining on Sunday. Of course, if we're talking probability, we're either going to refer to it as a decimal or as a percentage for the easiest sake. Okay, and so it's going to be like 30% or 71%. Okay, 21% or 71%. Okay. Any questions about that? No? All good?